Alright, so this video we're going to be switching gears from our previous discussions of estimating means for continuous and interval data, and now we're going to be looking at nominal and ordinal data. And instead of means, we're going to be estimating proportions. So like percentage of people and who agree with something, or percent male versus female, or percent whatever. And we're going to do this for large samples only. We're not going to look at small sample cases. It gets a little more complicated. So recall, a proportion is the characteristic over the sample size, x over n, and the converse of that is q, which is just 1 minus p. And p is always going to be less than 1 because we're looking at a subset of the sample. So we're going to be introducing a little more notation here. The hat sign that goes over a p or a q indicates that it's a proportion or a converse proportion for a sample. If we don't see the caret sign, we're looking at the actual population proportion or converse. So the procedure, kind of the same as we saw before, calculating the error term. I have a slightly different formula. The sampling distribution is normal, so we're back to z distribution. So the standard error of the proportion is what we're going to be calculating. And from that, we'll need a few pieces of information. So this is the confidence interval for p, proportion, where we have p hat minus e on the left side of the confidence interval. We have p right in the middle, and then we have p hat plus e on the right side of the confidence interval. So at different levels of confidence, we're going to know how wide this interval needs to be. So this is our formula for calculating E. Now we have the Z distribution. So we know, for instance, at the 95% confidence level, Z is 1.96. There are no degrees of freedom when we're looking at large samples. Remember, that's unique to the T distribution. And now this is the part that's different from looking at the mean estimation. Here we have the product of proportion and the converse proportion, right? So if that's 0.5 and that's 0.5, then that's going to be 0.025, right? And in the denominator, we have the sample size. So the square root of all that is what we're going to multiply by z. So for an example, at a 90% confidence level, right, so z is going to be a little smaller than 95%. We're going to calculate the error for U.S. adults who say baseball is their favorite sport. So we do a survey of 1,250 adults, and 450 say that yes, baseball is their favorite. So the proportion, x over n, 450 over 1,250, is going to be 0.36. So if we subtract that from 1, that gives us our converse of 0.64. So to calculate our error, we need to look up z at a 90% confidence level, which is 1.645 if you go to your z table, your distribution table. Multiply that by the square root of the product of the proportion and its converse, divided by the sample size, 1250. And when you work all that out, it comes out to 0.022. So our point estimate is our proportion, 0.36, plus or minus 0.022. So that comes out to 0.338 on the left side and 0.382 on the right side. So we're 90% confident that the actual population proportion that says baseball is their favorite is between 0.338 and 0.382, or 33% and 38%. Right.